Hello, geometry students. I'm so sorry that I cannot be with you today. We are going to try a lesson via video. Mind you, it's very difficult to talk to an empty room and this piece of paper with no student feedback on do I get it, I'm lost, what did that mean? Also, I can't pause this, so if I mess up, I just have to go with it. Alright, so yesterday we looked at reflecting points. Today is going to be very similar in the fact that we're going to reflect figures. Alright, so think about if I wanted to reflect a point, I have one point to look at and I reflect it over a line. Thinking about what a figure is, we know that figures are made up of lots of points, so we can actually just reflect multiple points and draw in the remaining parts of it, and we have reflected a figure. So essentially pretty easy after doing yesterday's work, okay? So I'm going to go ahead and show you an image that's reflected, that's in your book, so you can follow along in your book if you can't maybe see this very well. It doesn't zoom the greatest, but here we have our reflecting line. This is page 191. And we have our pre-image here, and our red one is our image. Okay, so we started with blue, ended with red. Okay, so this is a reflection of the whole image. You can see how we just reflected it like so. Alright, so we're going to look at things that we have to understand about a reflection of a figure. Okay, so the first thing is there's a one-to-one correspondence between points and their images. And all that means is every point in my pre-image is going to give me 1 point in my image. Okay, it's not going to give me 2 new ones. As we see with D here, D gives me 1 image, but it's the same point, and that's okay, as long as it doesn't make more than 1. Okay, B gave me 1 new, A gave me 1 new. Okay, so that's what one-to-one means. Okay, collinearity is preserved, meaning that if things are on a line to start with, they end on a line as well. So over here we see that A, B, and C are all on a line. Therefore, A prime, B prime, and C prime are going to be still on a line after the reflection. Betweenness is preserved. Okay, and that just means that if B is between A and C, then B prime is going to be between A prime and C prime. Distance is preserved. So that's saying the distance from A to B is going to be the same as the distance from A prime to B prime under the reflection. And lastly, angle measure is preserved. So the measure of angle ACE is going to be the same as the angle measure of A prime, C prime, E prime. All right. There's a whole lot there, and there's a really easy way to remember it. So if you flip the page, under this little 1 here, if I can get it in there, okay, this is a helpful little hint on how to remember all of that, okay? A, B, C, and D plus the one-to-one correspondence, okay? So let's write that instead of writing that whole postulate from the page before. So we're going to call this the reflection postulate. And we have to remember there's a one-to-one correspondence. Which again just says if I have 1 point under the reflection, it's going to give me 1 point. Okay? Then I have A, B, C, D. A is angle measure is preserved. Betweenness is preserved. Collinearity is preserved. And distance is preserved. All right, so that's an easy way to remember all of those things about a reflection. Okay, if you look in your book, example 1 is going to have you do a reflection, so you're welcome to follow that one. I'll demonstrate a really quick one to you. Okay, so this is a different example, but I think it'll suffice. Okay, so I'm going to go ahead, draw in a reflecting line. Then I'm just going to draw a really simple figure. Okay. And then go ahead and reflect it using the same ideas that we did yesterday. So first I'm going to extend my line so that I make sure my protractor can show 90. Okay. So then I'm just going to go ahead and line up my protractor with 90 on that line. Locate my first point, and again just find the same distance and mark that. We'll call that A and A prime. Alright, let's find the next point, like so, and let's see, 1, 2, 3, 4 and a half, 1, 2, 3, 4 and a half. We can call that B and B prime. And the last one, I'm going to flip this over so I can still match up my 90. And let's see, 1, 2 and a half. And we'll call this C and C prime. Okay, and we know that this is all these are points in here, but I don't need to reflect every single point. I can just reflect the points that are important or essential to that figure, which are the vertices. And then I can go ahead and connect. And this should be a pretty good reflection of ABC onto A prime, B prime, C prime. All right, although that doesn't look very good. Maybe I'm off on measuring, okay? So I think you get it. All right, so with that idea, there is this reflection figure theorem, and that's exactly what we just did. Okay, if a figure is determined by certain points, for example, the vertices, then its reflection image is the corresponding figure determined by reflecting those vertices. Okay, so same idea. Notice how we talked about yesterday that we can say the reflection of A is X. We can do that with whole images too, or figures. So the reflection of angle ABC equals angle XYZ. So we can kind of do the same thing that we did yesterday. Okay? Now, the last little idea is orientation. Okay? And this is a little different than the ABCD and the one-to-one correspondence, so that's why they separate it. Okay, so we just talked about how reflections keep angle measure, betweenness, collinearity, and distance, but they don't keep everything. We don't keep orientation. So this is one thing that doesn't stay the same and takes a little bit to think about, but just think about if you were going to walk around ABC in the triangle that we just drew, would you be able to walk A prime, B prime, C prime going the same direction? Okay, so let's look at that picture. If I wanted to go from A to B to C, so A to B to C, I'm turning to my right if you were walking, or I'm going clockwise. Versus, what if I'm going A prime, B prime to C prime? Notice how I'd have to turn left or go counterclockwise. So here, I'm turning right. Here, I would have to turn left, or as we said, clockwise. or counterclockwise? I screwed that up. No, that was right. Sorry, that was right. Counterclockwise or clockwise. Smiley faces for my mistakes. Okay? So, again, orientation is, think of it as how you could walk around or how you get around it. And so, in my pre-image, A, B to C, and around in that direction. Clockwise or turning to the right. But after I reflect it, counterclockwise. Okay? So, this is another part of the reflection postulate. Okay, so we'll add that. It says orientation is reversed. Okay? So, we're going to add that back up here in our reflection postulate. Orientation is reversed. Okay, and if you need a little note, this is how you walk around the figure. Okay? All right. Does that all make sense? If it doesn't, unfortunately, you can't ask me any questions until tomorrow. You could email me, I suppose. All right, so go ahead, get started on your homework. Best of luck. And we'll see if we ever want to try this whole video thing again. All right? Have a great day.